next up, we have Greg D'Elia of Slingmax. Again, during this presentation, please post your questions using the Q&A button at the bottom of your Zoom window, and Greg will answer your questions at the end of his session. And without further ado, I'd like to hand it over to Greg and Slingmax.
Thanks, Justin. As you said, my name is Greg D'Elia. I'm the Director of Engineering for Slingmax Rigging Solutions, and today I'm going to discuss synthetic sling cup protections. Most of us in the rigging industry have understood the importance of cup protection for many years now, and finally the standards are starting to catch up. This statement comes from the Web Sling and Tie Down Association. Shearing or cutting of the synthetic sling material is the single most common cause of accidents involving sling failure. In the new ASME B30.9 standard, it stated that slings in contact with edges, corners, protrusions, abrasive surfaces, or connecting hardware shall be protected with a material of sufficient strength, thickness, and construction to prevent damage. One of the biggest sources of confusion comes when we're talking about the difference between abrasion and cup protection. A lot of times we'll just talk about softeners and pads, but you really have to get specific. Abrasion protection is protection from external damage or wear due to frictional interaction with a surface. Most abrasion pads, they're actually a sacrificial material that wears out instead of the sling, and therefore you have to replace it periodically. Cup protection, on the other hand, that guards against damage from applied concentrated pressure from corners and edges. A lot of people ask, how rough does the surface have to be for you to need abrasion protection? And they'll ask, how sharp does an edge have to be to require cup protection? They'll want specific, minimum bend radiuses. And a lot of that is available, but really when you're dealing with the high stakes that we deal with in heavy lifting, the question doesn't really make sense. The real question is, what are you willing to risk by avoiding using protection? All slings should always be protected from all surfaces and edges. Unless you're directly connecting to, a trunnion or a shackle, you really need to use some sling protection. At Slingmax, we have two engineered products to help prevent cutting of slings, and they are the CornerMax pad and the CornerMax sleeve. The CornerMax pad is for applications where the sling is being protected from a 90-degree edge or corner. The actual geometry of the pad creates a tunnel where there's no contact with the edge. You can see on the examples, the two on the left, you see that they're used correctly. That tunnel is keeping the pad from actually touching that corner. So the only contact that is being made with the load is on those flat surfaces. The two examples on the right, however, because of the nature of how it works, the pad's not going to protect a sling that's rigged on a quarter that's 90 degrees, or if one side of the pad's not supported, like in the case of the second picture, you really need to block it out, like in the other example. For situations where you're not rigging on a 90-degree angle, pad style protection won't work. Then you need to move over to a sleeve material. In our case, it's the CornerMax sleeve, which is a special HMPE woven tubing. It's important to recognize that the cup protection comes from a combination of the material, the thickness, and the type of weave. So you really need the full thing. There's a lot of generic thin HMPE tubings available out there, but if they're not designed and tested for cup protection, you shouldn't be using them as cup protection. The sleeve has the advantage over the pad as it being easier to rig, especially if you're not sure exactly where the contact point's going to be. You can just use a longer sleeve and put that in place rather than trying to reposition a pad in the middle of a lift. Equally as important to testing and validating sling protection is to include a rating for the user. In our case, we rate our cup protections to 25,000 pounds per inch of sling width. It's important to consider the width of the sling being used, since that contact area between the sling and the surface is the important consideration. You don't want to have a situation where someone thinks by using a larger sized cut protection, they're going to get more protection because all that extra material on the sides isn't doing anything to stop cutting. So when a customer uses engineered cut protection, they minimize their risk, they protect the investment that they put into the rigging, they reduce downtime and costs, and they gain peace of mind. This chart here summarizes testing that we performed on the CornerMax products versus some other types of protection that are commonly available. You can see that we tested some competitor cut protection products. Ours slightly outperformed them. However, in the case of using old slings, where we simulated that by using single and double ply nylon, all the engineered cut protection, regardless of the manufacturer, was far superior to that. Especially you want to take note of the fact that a single ply nylon barely gave any additional protection over just the sling. And in addition to all the testing, we recently developed a new manual that addresses the correct use and care of the cut protection products. This will now be included with every shipment of cut protection that comes from Slingmax. It's been over 2 years in the making, including the all-important review by a human factors expert who conducted several focus groups to confirm that the warnings and instructions would be understood by the typical user. And if you don't know what a human factors expert is, they're experts in the area of warnings, instructions, usability. So they can really look at a set of warnings and tell you, is the average user going to understand what's going on? Will they correctly interpret these instructions or warnings and take the necessary actions, or is it going to confuse people in the field? And there's a couple levels of study that you can get into this, where you could just ask someone for their expert opinion, but if you want to go the full 9 yards, you have that human factors expert conduct focus groups where they actually take typical users, show them the proposed warnings, and have them answer what they believe that those things mean. And that's really the way that you know that your warnings are going to work in the field. Cutting is one of, or possibly the biggest cause of sling failures. 80% or more accidents with synthetic slings involve some type of cutting. Many, but not all still, users are now educated on protecting synthetic slings, but there's still a common assumption or misconception that steel needs no protection. However, we perform testing here at our headquarters that proves that's not the case. And really, we want to emphasize that all slings that are rigged on edge should always be protected. In order to test it, we put some different slings in our test bed, and we rigged them over a block of 4140 steel with 90-degree edges. You can see from the photo that it's truly a worst case scenario as far as rigging practices go. Even though we're going to show that the sling protection works great on there, in the real world, it would be very surprising to ever have to rig on something this sharp. So 5 tests were performed overall with 3 different types of slings: half-inch Flemish eye slings with and without cut protection, a polyester round sling without cut protection, and high-performance fiber round slings with and without cut protection. The Flemish eye sling had a 2.5-ton vertical and 5.1-ton basket working load limit, and it was rigged in a basket configuration over the steel block. And you can see here a video of the brake test. And as you can see, despite it being a steel wire rope, that block cut right through the strands until the entire piece of wire was cut. And here's the results. All the samples that we broke cut on the block before they reached MBL with an average force of 32,500 pounds or a 3.2 to 1 design factor. We also broke one control sling over a 3.5-inch pin, which broke at 49,600 pounds or a 4.9 to 1 design factor. The next test was the polyester roundsling that had a 9,000 pound vertical and 18,000 pound basket working load limit. Again, like before, it was rigged in a basket configuration around the cutting block. And I'll show you that test here. You can see again, the polyester roundsling cut right through. This time, the sling cut at 35,500 pounds, which is only a 2 to 1 design factor for that sling. Finally, we tested the twin pass sling, our high performance fiber round sling. The sling had a 10,000 pound vertical and 20,000 pound basket working load limit. And like all the other tests, it was rigged on the basket configuration around the cutting block. And we did rotate the cutting block after the steel test because they marred the edges. So we wanted to make sure every test was the same degree of severity. And here's that test. The twin pass sling achieved 60,000 pounds or a 3 to 1 design factor. After the unprotected tests, we then added quarter max sleeve to the same test configuration. This allowed the twin pass sling to make it to 92,800 pounds or a 4.6 to 1 design factor. Although quarter max sleeve is generally used with fiber round slings, we decided to test the Flemish eye sling to see what kind of protection it would give to a steel wire rope sling. I don't have a video for this one, but even though it's not a typical use for it, the sleeve did offer a modest protection to the steel sling as well, achieving 41,000 pounds or a 4 to 1 design factor. You can see here in the summary results that when rigging on an edge, the twin pass sling almost achieved its full 5 to 1 design factor when protected with corner max sleeve. And remember, that was a very extreme type of edge compared to what you would see in the field. The most unexpected finding, however, was that the unprotected twin pass sling and the unprotected Flemish eye sling had nearly the same results, 3.0 versus 3.2 to 1 design factor. When we started this testing, we knew that the steel would be affected by the edge, but not to that degree. Here's a complete chart of all the sling information and results, which can be shared if someone wants to see it and look a little more into the data. So what are the most important takeaways on cut protection? First, improvised cut protection like gloves, old slings, fire hose, pieces of rubber, they're proven to be ineffective. They depend on the riggers in the field to determine the correct material to use, and they're not designed for a specific sling type. Cut protection should be engineered and rated, and that rating should be tagged directly onto the pad or sleeve. The rating must take into account the cut protection being used and the sling is being used with. Capacity per width of sling is a common way of rating sling cut protections. And remember, all slings can cut on edges, so you should always use cut protection. Protection and sling combinations should be tested before use, or use engineered cut protection that is designed for the sling you're about to use. And specifically for rigging shops, you're going to want to rate and tag your cut protection. Provide instructions and warnings to go with it, and have those warnings and instructions reviewed by a human factors expert before distributing them to your customer. And that is the end of my presentation, and let's see if we have any questions.
Yeah, thank you, Greg, for your presentation. So now Greg will answer some questions that were sent to us during the presentation. And the first question being, have you done any testing over sharp edges with chain slings?
We haven't done with chain slings. It is something that I'd be really interested to seeing how it would go. But it is a bit more of a dangerous test to do, and we weren't able to do it in our shop yet. But I would like to see it happen.
Next question, are the cornerback sleeves available for wedge slings? And if so, up to what length or width, I mean?
We don't, so you could use it on a web sling. We don't generally recommend it because, you know, a lot of times the protection then will end up kind of costing more than the sling itself. But we have, the cornerback sleeve comes up in 10-inch width as a maximum, but two pieces can actually be sewn together and you can make a larger size.
And have you performed testing on cornerback sleeves to record results when used at working load limit and proof load to confirm that there was not any damage to the sling?
Yes, we've done testing, not to proof load, but to working load limit with the sleeve on there on edges to confirm that there was no damage. And in all the cases, there was not. We would take it up to the load, whether it's in a basket or a choke, hold it for a little bit, take it back down, take it out of the sleeve, inspect that there's no external or internal damage.
And which webbing distributors sell your Slingmax jacket?
Any of the Slingmax dealers will sell it, and it's too many to list right now, but if you just go on our website, slingmax.com, there's a full list and map showing where all the different dealers are.
And finally, what are the most common mistakes that people make when it comes to sling protection?
I mean, the most common is not using it. First of all, it's incredibly common and kind of disheartening for all the work that a lot of people have done in this industry to get people to use sling protection. But I think after that, the biggest mistake is not positioning the sling protection correctly between the load and the sling. Sometimes with pads, people won't bother positioning it at all, so it won't be making the correct contact with the corner. Or if there is a sleeve over it, they won't make sure that the sling is pulled taut and making full contact with the load before they start, and they'll let the crane take up the slack, and that's never a good practice. So I think lack of care in positioning it is the most common.
Okay, I think that's it for the questions. Thank you very much. I think you've presented a topic which should be top of mind for anyone using or selling any type of sling.